Hello, everyone, and welcome to Top Crop Manager's first webinar session for the Winter 2017, Spring 2018 season. My name is Janin Belbeck, and I'm one of the associate editors with Top Crop Manager magazine. I'm joined today by Tracey Baute, field crop entomologist with the Ontario Ministry of Agriculture, Food and Rural Affairs, otherwise known as OMAFRA. Today, during our free 60-minute presentation, Tracey will be covering Western bean cutworm in corn and edible beans and touch on topics such as scouting strategies, life cycle and behavior, and how to reduce the risk of crop quality concerns with this pest. We would like to thank Syngenta and Viptera for sponsoring our session today. Viptera from Syngenta is the only trait offering comprehensive control of damaging corn insects like Western bean cutworm. Viptera controls major leaf, stalk, and ear-feeding corn insects to reduce mold and mycotoxin production. Growers who trust Viptera enjoy superior insect and yield protection designed to fit their operations, higher quality grain, and peace of mind. It's time to put your foot down on pests. It's time to choose Viptera. Talk to your seed dealer today and remember to always read and follow label directions. Just a reminder that this webinar is approved for one certified crop science consultant CEU credit in integrated pest management, as well as one certified crop advisor CEU credit in integrated pest management. If you are applying for these credits today, please send an email to webinars@annexweb.com and outline which credit you'll be applying for, CCA or CCSC, your first and last name, and your CCA number where applicable. A recording of the webinar will be sent to your email 24 hours after the presentation. Just some housekeeping. Our session will run for a total of 60 minutes. So that means Tracey will present for approximately 40 to 45 minutes, at which point we will open up the floor to questions. If you have any questions for Tracey throughout the presentation, please type them in the questions tab in the GoToWebinar panel on the right side of your screen, and we will ask as many questions as we can in the time given. Don't forget, this is the first of a 6-part webinar series. We are adding new sessions and credit information as it becomes available, so be sure to check back regularly for updates at topcropmanager.com/webinars. So without further ado, I'm going to pass everything over to Tracey.
Thank you, and welcome everyone. As mentioned, I'm going to talk about Western bean cutworm. It has been present here in Ontario for almost 10 years now, 10 years next year. There's been some lessons learned, and what's interesting about this pest is that there are still some things to learn. And I'm very thankful for all of the researchers and collaborations that we've had so that we can better understand this pest as it's moved into the Great Lakes region. So I'm first going to talk about the history and go through a bit of the life cycle so you have a better understanding of it in association with the crop phenology, and then I will discuss scouting techniques as well as management strategies that we know so far and where we want to take it after that. So in terms of this pest, this is one of those interesting ones that it isn't actually an invasive species. It's a native species. It was documented back in Arizona in 1887. It was causing damage in dry beans in Colorado and Idaho in the early 20s to 40s. Started to see more interaction in corn in Nebraska in the 70s. And pretty much stayed in that region until about 1999 with some sporadic damage in Iowa and corn before that. Then it spread across, and it truly has become the primary pest for both Michigan and Ontario. Some would argue maybe even New York State. In terms of that range expansion, as I said before, prior to around the year 2000, it really was in the Great Lakes or Great Plains region. There was a note, a publication that stated it was found in Alberta in 1956. I followed through with my Alberta counterparts recently, and they confirmed that that was actually a misidentification. So when it did actually arrive here in Ontario, that was the first indication of it being in Canada. So as you can see in the lower image, its migration or range spread into Ontario by 2008, and then we had truly across Ontario in 2009, as well as in New York and Quebec and Pennsylvania. So as a native, it just had this huge range of expansion and causing problems since. Now, the real issue is when we were discussing with our the entomologist from Nebraska, who's been dealing with this for many years, he was concerned about it arriving here in the Great Lakes, mainly because of the humidity. He felt that we were going to have an increased success rate of both egg hatch and larval survival here in the Great Lakes region. And on top of that, we have two hosts that are also causing it to be able to thrive quite well. So what's interesting is that although we have some guidance from the research that was done in Nebraska and the Great Plains region, we've really had to take and modify scouting techniques, guidelines, thresholds, everything. And so we've really relied more heavily on partnering with Michigan State University, as well as researchers here at the University of Guelph Ridgetown campus and others to really get a better understanding of it here. In terms of its host range, well, despite its name, cutworm, it doesn't actually cut plants at all. It feeds on the reproductive parts of the plants. So whether that's the corn ear or the bean pod. It is, the main hosts are all corn types as well as all bean types. There was some early research that indicated that soybeans, squash, and even the nightshade families, tomatoes, peppers, etc., could be potential hosts, especially done with lab studies showing that it may feed on them, but we have not seen it naturally develop on these crops. And so we still feel that it truly is a corn and edible bean and other bean type risk. And of course, here in Ontario, Michigan, and New York in particular, we have those two crops. So that's really allowing it to thrive here. What's also very fascinating about this pest is that it behaves differently in corn and beans. So in corn, you can see all stages of this insect during the day. You can find eggs easily, you can find larvae in the ear later in the season. So it lends to scouting and providing good recommendations for management in that crop. In beans, it's a little different. Only the very young larvae are active during the day, and then by the time they're in the mid and late instars, they're only active at night, hiding out in the ground during the day. You're very hard pressed to find any eggs or larvae active in the plant, in that crop, until you actually see holes on the pod. So it's made a little bit more difficult to establish some good scouting guidelines and management for that crop in particular. I'm next going to go through the life cycle and how to identify this pest before getting into its impact. There is just one generation per year, despite some thinking that surely there's more because it's present in the province for quite some time during the season, but that's simply not the case. So first, interestingly, it overwinters as a prepupa and pupates in the spring sometime around May or June. The moth then comes out of the soil sometime in early July, as indications from the University of Guelph Ridgetown campus here, the work they've done. But clearly, emergence must be occurring elsewhere earlier, because we do see moths entering and arriving in our traps by early June. We also think that emergence is staggered because we see adults throughout the season, and despite them having a very short lifespan. So there's still some dynamics, some research on this that could be done, but we feel this is pretty strong in that we're getting moths emerging, and they have overwintered successfully here in Ontario. Where we've had in at least the initial first 5 years, we've had some really strong hot spots, both in what we'd call like the Bothwell area, as well as the Norfolk Tillsonburg area, where we have very sandy soils. So we felt that there was a strong association with sandy soils and success rate of overwintering. Some research from Western University indicates that there may be other soil types that they can successfully overwinter in on occasion. And it also lends to, now that we're seeing moths spreading farther and farther every year and more frequent across the province, there are likely these other regions at the very least that they could successfully overwinter in those sandy soil types. We also here in Ontario deal with not only our resident population, but migrant populations. So wind fronts carry, whether it's from Michigan or beyond. And I've also seen where later in the season we've had wind dynamics carrying back from Quebec down into Ontario. So we've got this ebb and flow of moths moving around in this region. I will say this year in particular, we had an agronomist, a local agronomist who was in PEI in Nova Scotia and confirmed that he found moths, sent us text message actually with photos of Western bean there. That's not saying that's the first year it's been there, but we have confirmation that at least it has spread now into the Atlantic provinces as well. The adult moths themselves, as mentioned, they're present in Ontario from June until about early September, with peak flight taking place somewhere around late July. It varies by region, and I'll get into that in a little bit. The female moths actually are the ones that emerge first from the soil, and they sexually mature in about 4 to 6 days, and then they mate about 3 times in their lifespan. They can lay anywhere from 300 to 400 eggs in their lifespan, and both the males and the females live for about 7 to 9 days, males living shorter. To identify them, they're actually quite pretty in coloration, if you want for an entomologist to say. There's some distinguishing features though. They're approximately 2 centimeters long, and they have a white band along their wing margin, as well as these very identifiable distinct markings of a full moon and a boomerang. Not many other moths have similar markings, and so knowing that they have the full moon and the boomerang really indicate that that's Western bean. As well, they fold the one wing over the other almost to the very end of the wingtip, so it almost lines them up, and that's kind of important because when you're trapping, you may lose their markings and need to identify them just based on shape, which I'll show in a few moments. The moths, they typically fly at night and mate at night, but you might find them resting, particularly the females, in the leaf axils in corn. But research from Michigan State University has found, a poor grad student had to stay up all night, and she found that the majority of the moths were flying somewhere between 1 and 3 a.m. This is the more realistic version of the Western bean cutworm moths that you'd see. This is from traps, and this is very common. When you get a number of moths accumulating in the traps and you don't check them for a few days, they start to rub off the scales on their wings while they're dying, and you lose all their markings. So you really have to then somewhat identify them based on their shape, and knowing that the majority are of that shape, and are likely Western bean because of the pheromone that is used to trap them with. What's interesting is that they have a very strong preference to crop stage. Crop stage probably plays the biggest role in which field actually sees the infestations. So the mum moth somehow knows, whether she's getting cues from tassel, that she wants to lay her eggs in pre-tassel to full tassel corn. So corn that is in the vegetative stage that doesn't have a tassel, you can't feel a tassel growing inside that whorl, even though she might lay her eggs on those, those larvae won't survive. Where she really prefers to lay her eggs is where there's an actual tassel for the larva to feed on. Once you start to get past that full tassel and the tassel starts drying down, that's when dry beans or later planted corn would be the more preferred crop to lay their eggs on. So as I alluded to, if there's no tassel on developing in that plant, those newly hatched larvae will die within a day or so. So really to focus on scouting efforts, really hone in on fields that are at the very least having a tassel developing in the whorl. But what we're seeing, and this has happened for the last few years in Ontario, is that variable growth stages or crop stages are happening in individual fields. So likely that's allowing the moth to stay put in each field and just move to the different areas within the field that are in that more ideal growth stage for her to lay her eggs. The eggs themselves are round. The masses can have 50 to 84 eggs or so, some more, some less. They have longitudinal striations, that kind of like cantaloupes, and they're pearly white when they're first laid. These eggs will hatch in about a week, and I'll show you a picture of that next. And peak laying obviously would happen just shortly after peak moth flight. So that's why we use these traps to monitor when the majority of the moths are out and flying around and mating, and likely also going to lay their eggs. So there is just the transition from that pearly white freshly laid egg all the way to 5 to 6 days when they turn purple and begin to hatch. And that's a good indication once you start seeing purple eggs that you're going to have larvae on those plants very soon. Interestingly, in corn, they lay their eggs on the hairy surface of the leaf, on the upper surface, as well on the top 2 or 3 leaves of the plant when there's a tassel. Now, we have had some anecdotal comments from scouts that later in the season they see some eggs directly laid on the corn husk. Maybe the moth is getting cues from the silks themselves. But that isn't a very common scenario. The majority, again, and I think that's when the moth is desperate to lay her eggs and can't find a more ideal crop to lay her eggs on. So, but the majority are going to be at the upper part of the plant. In dry beans, it's the opposite. They like to lay their eggs on the underside of the leaves, deeper in the canopy, so it's very difficult. I think this is one of the only pictures we've had of western bean egg mass and young larvae on the dry beans to take a picture of. It's just very difficult to find happening in the field. Once those eggs hatch, they go through 6 instars in about 30 days and change, obviously grow bigger as they do that. Initially, they feed on the eggshell. And then the larva can only survive on either tassel, a little bit of pollen, or in the case of dry beans, the flowers. But really, they want the silks or kernels or pods or seeds. So they really can only survive for a short period on the tassel and pollen or flowering part of the plant. They're not cannibals, though, so that's the reason why they can have such an impact too, because you can have multiple larvae per year, and they move from plant to plant. So this is a very mobile pest compared to others, even in the larval stage. I should have mentioned too, you don't see much, if any, leaf feeding, and so that has some implications on insecticide application that we'll talk about in a little bit. So there's just a picture of when they first hatch. They're very tiny, and these would feed on their egg shells before they move and migrate directly up to the tassel. What's interesting about this pest as well is that it changes its look over time. So when it first is very young, in those first instar or second instar stage, they have spots very similar to what corn borer looked like. That corn borer has less distinct spots, and a dark. These have a dark head and dark legs. Those are the ones that would be moving up to the tassel for a few days, and then they'll walk back down to where the ear is. Within that same week, they change their look again. Second to about 4th instar larvae start to look like armyworm, where they have very distinct stripes along their body. With the exception with armyworm, armyworm have bands on those chubby prolegs that they have, whereas western bean doesn't. And as well, western bean has quite a gap between their front legs and those prolegs, which causes them to actually let's say, crawl up like a inchworm, squirming from having their back legs catch up to their front legs before they move forward. So if you see something looping up and down a plant, that's likely western bean cutworm. Once it's in its final instar stages, it loses, or at least the stripes that were along its body become very pale, but very dominant 2 broad stripes show up on its pronotum just behind its head. So that tells you that's definitely Western bean. If you find anything in the ear that has those 2 broad bands, it's Western bean cutworm. As I mentioned, they're very mobile. So that one individual egg mass, if there's 50 and they successfully all survive, those larvae will branch out, walk around, and you can literally find ear after ear or pod after pod of feeding in that area, 12 feet within the row and 10 feet across or more. So it's very spotty and can have a big impact coming from one egg mass. Then they overwinter. So late in the summer, early fall, those 6 instar larvae drop from the plant and bury themselves into the soil, and they can go quite deep depending on the soil type. They then create this pre-pupal chamber with their saliva, and it's understood to potentially help them and protect them from frost heaving and water logging. And work from Western, as I mentioned before, is showing that it can actually overwinter successfully in other soil types, not just sandy soils. Not as frequently successful at that, but it still, it can happen. But there is, I would say, if there's any susceptible stage, it is this stage of the pest while it's overwintering. And there is some high overwintering mortality that occurs just in general. There's just a picture of the actual larva when it's burrowing into the soil in the fall. So yield and quality. In corn, this is typically just an ear tip feeder, but if there is more than one larva in the plant or on that ear, then you will see more aggressive feeding throughout the ear. Studies have shown anywhere from 3 to 15 bushel an acre loss, but I would argue that really where the big impact is that this pest opens up the ear to mycotoxin development and ear molds. There's just a picture of that. And what also exacerbates it is that birds love to come in and scratch at the ear tip and find the larva to feed. And so that also adds to the exposing the ear to the ear molds and vomitoxins that can develop. Work by Jocelyn Smith here at Ridgetown actually looked into this using various hybrids, Viptera being controlling Western bean, where others were very susceptible to Western bean. And she did find some relationship with fumonisin and other mycotoxins developing. What you will see in this graph, though, is that there was still dawn appearing in the Viptera hybrid, and that just alludes to that, yes, although Western bean cutworm damage can have an impact on the development of these mycotoxins, it also comes down to the actual hybrid itself and its ability. So though injury by Western bean can increase dawn levels, hybrid tolerance to fusarium and environmental conditions play the predominant role. But we do really recommend that when you are selecting hybrids, do so based on their tolerance to ear rot pathogens, particularly fusarium, to reduce the risk of these mycotoxins. Thankfully, this year seems to be a little bit less of a risk of vomitoxins. The study, there's always been a provincial study being done for the last 7 years by my counterparts, Albert Tenuta and our corn specialists. And last year, 2016, was a particularly bad year for especially higher levels of dawn. This year is a little less so, which is a good thing. So environmental conditions do still play a role, though they will say that some of these sites did have significant Western bean cutworm injury, which is likely associated with some of these results. In beans, interestingly, the first and second instars do a small amount of feeding on foliar, but they'll go to the flowers if there's nothing else for them. But by the time they're in their third Instar, they are essentially feeding only at night and focus on the pods themselves. And that's what's really frustrating about this pest in this crop, because you can't find them during the day. And if you've ever walked a dry bean field, the pods are not necessarily the easiest to spot. So it can be difficult to find the injury and enact a management strategy in time. We first started seeing injury in beans about 2014. We did have a grad student on this crop, but of course we hardly had any field infestations before 2014. So she unfortunately didn't get a lot of the research she wanted to do in the fields, but now we're hoping to get another one established so that we can start looking into this problem again. Some research from Michigan State showed up to a 15% yield reduction, but really what plays a bigger role is that they cause these picks, which can cause whole loads to be rejected. At the very least, those beans have to be sorted and cleaned, and they get downgraded. So it's a cost to the grower and also the elevators to deal with this pest. Now I will cover off trapping and scouting techniques that we've been using and have been developing. So way back when this first started, Nebraska and others were recommending the use of this milk jug trap on the top left. And that was a very cheap and effective way of actually monitoring and detecting the pest being here. It's cutting holes into a milk jug, placing antifreeze in the bottom with a pheromone lure, and catching and observing moths. The moths would get stuck in and ping around inside the jug and land in the antifreeze and die. Problem with this trap itself is that we would either get the antifreeze would evaporate, or a heavy rain would wash this out, or you would get a thick layer of moths accumulating on the bottom, and essentially any new moths coming in wouldn't actually be touching the antifreeze and falling in. So it isn't as effective as these bucket traps that we've now been trying to move everyone to using. So these are full green universal traps. You put a vapor strip or impregnated piece of plastic inside so that the moth, when they enter, will die, and you have a pheromone lure. And so these are set up along the field's edge. You can monitor them weekly, preferably more frequently, as I showed you the picture earlier. As the moths start to accumulate, you start to question if they are Western bean. But this trap itself, it can last for 10 years or more. A new system that we're testing out is a Z trap. So it's, again, essentially a bucket trap with the pheromone as well in the vapor strip. But inside here are electric tines that actually count every time something enters that trap. And on top of it is an LED battery and a cell reception. And so it will send those results on a daily basis to a tablet or phone and tell you what the trap counts are that day. So we are testing this out. It's a company from Indiana, Spectrum, and both myself and Michigan are looking into how successful this can be. It's expensive though, $400 a trap per year, but you can see over time as technology gets cheaper, this is likely the route that a lot of trapping is going to go, where everything is automated in real time. So those traps are set up anytime in June, and we monitor till about late August. You can place one trap in a cornfield, but we recommend 2 traps in any edible bean field, just to really get a sense of the presence of the pest. And we prefer to have it in the prevailing wind side so that the plume of the pheromone is blowing into the field that you're trying to monitor. So you're actually attracting the moths from your field into this trap to see what is present. If you put 2, we recommend putting at least 50 meters between them so that the pheromones don't conflict with each other. The bucket itself should be about 4 feet above the ground. Check at least weekly. And those pheromone lures should be changed every 3 weeks because they lose their potency. And of course, keep those lures that you're not using in the freezer until you are going to use them. There's misconceptions, though, what the traps are doing for you. A lot of people think that it should be an indication of threshold. And especially in the case of corn, that's not the case. These really are indicating just the presence of the moth in the region and when you're seeing peak flight. So you know when peak egg laying is taking place. We're only catching males in the trap, so it's not necessarily going to indicate all of the moths that are out there and what activity is going on. So it's still very important to be going in and scouting the fields that have traps in them. And most importantly, you know, everyone has been assuming it's only a problem in our hotspot regions in the province. Really, we're seeing that it has changed. They're really moving and spreading across the field every year now. And so it's actually more important, the areas outside of these hotspots, to be trapping so that you know and are aware when the moths are present. Interestingly, I started setting up traps in Ontario in 2007. So we've had a trap network going for 10 years now. Over that time, we've accumulated 2,500 trap locations and captured over 858,000 moths. So I would like to think that we've had a little bit of an impact on their presence and taken some males away at least. But clearly, even though we're catching that many in 10 years, this pest can still be a problem in fields. So the traps really are just a monitoring tool, not a control tool. We have, as I mentioned, the Western Mean Cutworm Trap Network on the Canadian Corn Pest Coalition website. Any participant is welcome to join, sign up as a user, and submit their trap counts every week. And then we have interactive maps developed through OMAFRAT, our GIS group, and they've developed these interactive weekly maps that you can actually hone in even deeper into, closer into your location and see what is going on in your area. And we've been fortunate to have both now Michigan and Quebec has also been involved. And so we've got quite a system of monitoring for this pest now. And we hope to even take the data that we've collected further and try and help develop some new predictive tools. But this slide here is showing you when the peak week that took place, at least for the southwest of Ontario. And that's the typical norm that we'd see in these trap years. As I showed, here's a graph of that, indicating that typically on average, the province would peak around the week 9, which would be anywhere between July 24th and 30th. But that is an overall average. When you actually start looking at the data a little closer, each region peaks a little bit differently. So Essex in particular in this year peaked early, which was in week 8, July 17th, where the majority of the rest of the Southwest peaked in that week 9. As you move east, you start to see the peak happen a little later. And so this is important, especially when you've got to decide when the majority of the moths are flying around and what fields are at risk in your locations. So as much as we follow this provincial peak, you know, I really suggest, and that's why we do the trap network, to get a sense of where the regions are peaking differently, and scouting and management strategies also adapt to those. Overall, in those so far 10 years that we've been monitoring, really, again, the average is peaking around week 9, with a couple of years, 2012 and also 2013, varying from that week 9. So we're going to tap into that data and really figure out what happened and why, and help better model when we expect peaks to happen each year. Why we monitor peak is because of this. So we're seeing more and more growers and scouts jumping the gun a bit on management in particular. So yes, there are going to be moths laying eggs prior to peak, but unless there is a tassel present, those larvae are going to die. And unfortunately, I'm seeing some growers jump at the gun and spray early, even prior to the tassel being completely out. And that's leaving a long window still of peak flight and peak egg laying happening for weeks after that. So really, you want to try and manage and time everything so that you're going in right around peak, monitoring for this pest, and then applying a management strategy during peak egg laying shortly after so that you're getting the most control. Spraying earlier into this blue time period, unless you're the earliest field in the area and you've got a lot of moths going in to your field, I think, you know, there's some adjustments that need to be made to manage and scout according to your region's peak flight time. And of course, also your ideal growth stage, which I'll talk about next. So thresholds and management. Scouting in corn is actually not terrible. Of course, you want to have a face shield to do most of it because you want to, as we say, blitz the field and go up and down these rows as quickly as possible and look for eggs. But if you have traps up and they detect that moths are present, then focus your efforts in scouting in fields that are in the ideal growth stages. So pre-tassel to full tassel, the ones that the mom moths want to lay their eggs in. Scout 10 plants in those ideal areas. Try to get a sense of about 100 plants in those ideal growth stages. Scout every 5 to 6 days for at least 2 or 3 weeks so you get a good sense of activity. And take count of the number of plants that you have found egg masses on. And now we've changed this where we want you to accumulate those number of plants over a 2 to 3 week period to determine threshold. The nice thing in corn, as I mentioned, is that they lay eggs at the top of the plant, so you can actually physically see them a bit better and use the shadow or the sun to your advantage, putting the plants between you and the sun so that you can actually see the shadow of the eggs as you walk and look at the tops of these plants. Previously, the threshold was 5% of the plants scouted with egg masses or small larvae. That was actually bumped down from Nebraska and Great Plains threshold of 8%. And it was spraying at full tassel when the majority of the egg masses have hatched. We've adjusted that. We're feeling that we're just getting too much. There's a longer period of egg laying going on. You need to accumulate that 5%. So if 5% of the plants over a 2 or 3 week period have egg masses, you likely need to spray. And even likely the threshold will need to be lowered if you planted a fusarium susceptible hybrid. Historically, the recommendation was to spray at full tassel. But as I said before, I think there's such a long egg laying period that I'm worried that too many are going in just when the tassel's coming out and spraying, and we've still got moths laying eggs and larvae developing on those plants after that. All of these Western bean cutworm larvae only feed on tassel, silk, or kernels, and they can't live on the tassel for very long. So we're trying to now suggest that we focus on spraying the ear, because no matter what, all of the larvae on that plant will make their way down to the ear zone and feed on the ear. So spraying when there's fresh silks will allow the insecticide, the activity for them to be exposed to the insecticide. And it also gives you a chance to tank mix with a fungicide if ear mold is actually a concern as well. So instead of focusing on the tassel at the tassel zone when early tassel is happening, hold off a little longer so that you know even if there's been more eggs laid in that week or so, all of those larvae are coming down to that ear and going to take a nip of those fresh silks before entering the ear. So that's the opportunity to really get them. We have a number of insecticides registered on corn, thankfully of different chemical groups. I often get the question, is one better than the other? No, all the studies we've done show they're equivalent. They give good control. I think where you see the advantage is going with ground application so that you're ensuring good coverage on the plants themselves, and especially now if we need to start more focusing on the ear zone rather than the tassel. What I also strongly encourage is that we rotate chemistries. I know a lot of people who are going to the diamide group, which is for various reasons, but a lot with the less risk to beneficials, for example. But I'm also worried that because there's area-wide use of one product, we're going to develop resistance. So we really encourage that you rotate chemistries each year. If you really want to stick to the diamides, then I suggest also adding or doing Volume Express, where you've got 2 actual chemical families in one. So there's 2 different modes of action. The larva itself is less likely to develop resistance to a product that would have 2. That said, unfortunately, right now, Fumarate is reevaluating cyhalothrin lambda, or lambda cyhalothrin active, which is in Matador and Volume Express. So there's a chance that we could lose those products, and then we'd be reduced down to only 2 to rotate our chemistries. But of course, there's also the opportunity to use Transgenics. On any Cry1F or Herculex Smart Stacks does not provide protection anymore to Western bean. We have developed tolerance or resistance to that Cry. Only hybrids, the Viptera hybrids with Cry3A in them provides control right now. So keep that in mind when you're selecting your transgenic options. And there's just a photo to show when we started to see that tolerance take place in Smart Stacks varieties with that Cry1F. It just no longer provides any protection. In corn, you can harvest early as well. Plant as early as possible so that you're not in the ideal growth stage when the moths are out flying around and wanting to lay eggs. Really, again, this comes down to quality. So I recommend that you scout in the early fall and harvest early if you are seeing ear molds develop. And of course, select hybrids that are less susceptible to ear molds and vomitoxin development. In dry beans, it's a little different. Unfortunately, it's almost impossible to find any eggs or larvae active in the field, despite our efforts, scouts' efforts, grad students' efforts. So, and dry beans are mostly more at risk once the neighboring cornfields are past that ideal growth stage. So we suggest you monitor with traps to see if the moth is present in your area and determine when peak flight happens. Then go into adjacent fields, scout them, because that's where you're going to find the actual presence of the larvae or the eggs. And knowing that if the adjacent cornfield has reached threshold and needed to be sprayed, likely so does your bean field shortly after. But I say shortly after, wait until pods are present. I know some growers who move right from spraying their corn to going and spraying their dry beans, and I think that's too early. You want to have pods present when you spray to actually have activity on this pest. So we encourage scouting 10 plants, 10 areas of field once you have early pods. Look, typically pod feeding happens about 10 to 20 days after peak flight. So look for any tiny feeding signs of grazing on the surface of the pod. Make sure it's not something else like slugs, and then look for tiny holes. And you can still get good control even once they start feeding on the pods. Original Nebraska thresholds was 1 to 2 larvae per foot of row. But I don't know how they ever came to that because it's really difficult to find. They also had an accumulative threshold with traps where if you accumulated 1,000 moths or more, you would likely have to treat. Well, as I alluded, you can't find them in the field, but also most of the trap locations that we have every year hardly ever accumulate more than 700, well, on average at least. By the time you get to peak flight or shortly after. And I think this just is way too high a numbers for our situation here in the Great Lakes. So we just can't rely on those. Instead, we don't have a threshold yet, but we suggest, if scouting and you find early feeding, then a spray is likely necessary. The chance of you finding one hole, there's likely many more around that. That's experience talking from walking into a field late in the season and seeing so many more pods with holes in them. Michigan is actually suggesting that trap sites that start to accumulate more than 150 moths per trap will likely need to be sprayed. And then the positive thing with dry beans, at least, is that control is actually pretty decent. Western bean exits a pod before dawn and hides in the soil, and then very next night they enter a new pod. And so there's the opportunity to expose them to insecticide if there's still some on the surface of the pod. So spraying when there's a pod is the most important. I think too many are spraying before the pod's present, and you're not getting actual activity on this larva because they're not feeding really actively on the plant until there's a pod there. There again is products registered in dry beans, not as many. And again, unfortunately, 2 of them are potentially at risk. They're being reevaluated right now. But we do hope to try and get more products registered on dry beans soon to help rotate our chemistries. Because if there's one pest that can develop resistance, it's this one. Positive thing is we are starting to see natural enemy activity. There's egg parasitoids, there's pathogens and predators, and so there's more work going on to determine the impact that natural enemies can have. Fortunately, when we see widespread spraying going on, that is reducing their likelihood of coming in and having some activity. But I see over time that there'll be a balance that comes into play, and more natural enemies recognize that corn once again has something to feed on. And finally, future and current research that we're doing, we're going to work hard on the trap network and maybe even add more to that, develop prediction models, crop staging models to help improve spray timing and scouting. New actives are being tested, biocontrol assessments. Ridgetown here is going to focus on mycotoxin management and determining if thresholds have to change according to susceptibility to mycotoxins. I think there's some window to improve insecticide timing and especially the nozzles and way we're applying them on the crop. And then, of course, too, we hope to be monitoring more for resistance because that is our concern, both from transgenic point of view as well as foliar insecticides. There's lots of resources that we try to provide on this pest, Field Crop News, the Trap Network. We put info sheets and trapping instructions. Follow a few of these individuals on Twitter, Pest Manager app as well, and of course our publications that we produce here at OMAFRA. And of course I do want to thank, because over these 10 years it's taken a army of researchers and extension people to try and figure out this pest. We haven't learned everything, but we certainly have opportunity. We've learned lots, and there's opportunity to still learn more. So I'm very thankful to have the individuals that have been helping with this and the support that we get from our commodity organizations to do this work. So with that, I will soon take questions.
Awesome. Thank you so much, Tracey. It's a great presentation. We would like to once again thank Syngenta for sponsoring this webinar session on Western bean cutworm. Now we're going to open up the floor to some of our audience questions. Apologies ahead of time if we can't get to your questions today. So let's see here. We have a question that says moths lay 50 to 84 eggs at a time, but they can lay up to, as you mentioned, Tracey, 300 to 400 over their life cycle. Mm-hmm. This attendee asked, does that mean a moth will lay multiple times? Is this once per day? If it does lay multiple times, is this in the same field, or will they move to other adjacent fields to lay?
Oh, that's a good question. I can't say that we know everything about them. I do believe that some of the grad work that's been going on at various locations, they've found they lay eggs to about 3 times. Each female, 3 different egg masses. And I would suggest that likely within the same field. So I can't say though whether it's that same night, but over the course of the week that they are alive, they have already mated. These females, we do know, will mate more than once and with different males, so they're not they're polygamous, so to speak, and will I would also argue maybe lay smaller egg masses in a number of plants, not just limiting themselves to 3. So, but I think with the activity that we're seeing in the variable growth stage within fields that's been taking place, whether from spring conditions, etc., they're likely more to stay within the field or the adjacent one while they're laying those eggs.
Okay, perfect. Another question, what percentage of larvae from the egg mass typically survive, and what factors affect this?
Great question. Some of the grad research is still working on and determining that, but I would say, let's say in Nebraska, where 30 to 50% of the egg masses would survive. Here in the Great Lakes, that's much more. You could see anywhere to 80, 90%. Now that can change. Some of that will be decreased with the incoming natural enemies now that we're seeing becoming more prolific in these fields. We're seeing some just not completely hatch, and whether that's egg parasitoids or environmental conditions that kept them from actually hatching, not sure yet. So there's some things. Interestingly, some of our sites in the hotspot regions this year in particular had very low western bean. They've been known to have them for a decade, and now we're seeing a significant drop in population. So we're going to investigate those locations and see what's at play there. But at the beginning, when this pest has arrived, it's doing quite well in our humid environment.
Awesome. So we're hearing a lot of things with climate change, colder winters, warmer summers. So if we do have a particularly cold winter, does that affect western bean cutworm? Does that mean that they're going to be less of a problem for us?
Well, yes and no. We know that they can successfully overwinter, especially in sandy soil. They can get down deep, and they're not as impacted by winter climate because of that. Of course, the milder the winter, the more successful they will be in any of the different soil types. So even in clay, where they might not get down as deep, they could survive. So yes, you could knock back quite a few that are in those other soil types. Our problem is that we also, even if after a harsh winter, we still get moths coming from other locations, Michigan and beyond. And so we seem to get enough of a flush of moths to successfully give us a decent infestation level to at least require some locations to need to manage them. That's why traps come into play. It really tells you if they're active and aggressive, so to speak, in each region with moths and egg laying to need to go and scout and manage.
Okay, I just got one in as you were answering that question. If you foresee the pressure increasing in the future with more overwintering potential, does this mean the egg-laying period will continue to be more spread out with native and blown-in moths?
Well, it all comes, I think, part of what really plays a role is the crop staging. So if a lot of growers get their crop in early, and it all pollinates or tassels at the same time, then I think there's less opportunity for the moths to really lay their eggs in a longer period of time over the season. What's been, I think, hurting us is these springs where we get such a delay and variation in planting dates, and so that different fields are flowering at different times, and it's just giving them that landscape to move around in. I can't say for sure what's going to happen over time. I mean, we have seen where over time something getting more endemic and normal here also brings in more pathogens, other things that can help us knock down that pest even further. So I don't foresee this being a problem forever, but it's something that we can't ignore until we start to see more of the natural pathogens and natural enemies having a bigger impact. And who knows, climate change may start to make it less ideal for them. they may actually use up too many resources in the fall as they try to get ready to overwinter, burning more calories, so to speak, and not be able to successfully overwinter. Those are some of the things that Western and other grad student projects are looking into to determine. So stay tuned. As I said, there's always things that we're learning about this one.
Awesome. Another question, if there are any predators to this insect?
Yes, for sure. I can move back to definitely ladybugs. I would say that if there was any that I'm noticing more, because I did my master's way back when I'm aging myself, on corn borer, and back then you would see a lot of different natural enemies prior to BT coming in and knocking that pest away. Now we're finally seeing that these natural enemies are recognizing, hey, corn has something to feed on again. So we have ladybugs, both adults and larvae. We're seeing, as Chris's picture here, we've got lacewing larvae, and even some parasitoids. And a colleague in the States is actually looking at trichogramma, a small, tiny wasp that we used to release for corn borer, seeing how successful it actually would be at parasitizing Western bean as well. So there could be in the future trichocraps or pellets that we put out in the field to release these trichogramma wasps and parasitize our Western bean. And as Jocelyn has seen with this, also viruses and pathogens that come in and take it down. So there's opportunity, and especially as I alluded to, that overwintering stage that stays in the soil for so long. Surely there's got to be some soil pathogens or other mechanisms for us to play around with to get and knock back that population even more that's overwintering.
Perfect. So with regards to these pests in bean fields, if the tassels are so important for larvae survival, what are they surviving on in bean fields? Is the survival rate actually lower in bean fields?
Good question. Don't know that answer yet. Potentially, I would say there is definitely some feeding that goes on. Let me go back to the actual flowers. So if there's at least a flower, let me find that picture, they will feed on the flower, and as well as, so this is a flower of the beans, as well as the very tiny pin pods. And we do know that they will do more foliar feeding on beans than I see on corn. They don't at all on corn. There's a bit of foliar feeding on beans, so they can survive, but they really do need that pod to be there shortly after for them to truly be able to continue their life cycle. So there is a short window, and again, I think the dynamics of what the cornfield nearby is doing plays a big role in how they do and if they prefer to go to that dry bean field instead.
Awesome. Well, that takes up our time today. Thank you so much, Tracey, for answering our attendees' questions and for presenting today. Just a reminder to our attendees to email us at webinars@annexweb.com to get your CCA or CCSC credits. Once again, this presentation will be made available to you within 24 hours. So thanks again, Tracey.
You're welcome. Thank you for having me.